So today we're going to be going over a Hess's law problem. And this problem gives us the following three equations. Strontium oxide plus CO2 yields strontium carbonate. 2 strontium oxide yields 2 strontium plus 2 oxygen gas. And 2 strontium carbonate yields 2 strontium plus 2 solid carbon plus 3 oxygen gas. And you'll notice that the delta H values are given as negative 234 kilojoules, positive 1,184 kilojoules, and positive 2,440 kilojoules. And the problem is asking us to find the delta H of the following reaction. Carbon plus O2 gas yields CO2 gas. For this problem, we will need to know Hess's law. And Hess's law tells us that the heat of any reaction delta H final, which is what we were looking for in this problem, for a specific reaction is equal to the sum of the heats of reaction, which is our delta H values from the three equations, for any set of reactions which in sum are equivalent to the overall reaction. So we are going to be adding up the following three equations so that they cancel out and equal our last equation. So let's start on the solution. So first we're going to name our equations. The first one being A, second B, and the third C. I like to do this to manipulate each equation and have it be easy to work with. Our next step is going to be to analyze what must happen to each equation for them to equal the final equation. So we look at equation A and we see strontium oxide. What you'll notice about strontium oxide is that it doesn't show up in our final reaction. So we are not going to start with strontium oxide. Instead, we look at the next compound. It's going to be carbon dioxide. And we see that carbon dioxide also shows up in the final reaction, but it's on the product side. So we're going to need to flip equation A so that it looks like the final equation. And we do this by multiplying everything by -1, including the delta H value. It's very important that we multiply the delta H value to get the correct answer in the end. After we do that, we get strontium carbonate yields strontium oxide plus CO2 gas. And we are done with equation A. So for now, we're going to skip equation B, and we're going to come back to it later. I will explain why later, but for now, let's just skip it and move on to equation C. So in equation C, we see that our 2 carbon solid and 3 oxygen gas are on our product side, but in our final reaction, it's in our reactant side. So we're going to do the same thing we did in equation A, and we are going to flip it. Once we flip it, we're going to see that 2 carbon solid plus 3 oxygen gas plus our 2 strontium solid are going to be on our reactant side. But we see that there's only 1 carbon solid. So we're going to divide everything by 2. So we end up with 1 carbon solid. Now we're going to come back to equation B. And what you'll notice is that none of the molecules show up in the final reaction. So none of the molecules in equation B we see in the final equation. So we're going to use it to cancel anything we don't want in equations A and C so that they equal the final equations. So far we have those equations for A and C. Strontium carbonate yields strontium oxide plus CO2 gas, and strontium plus carbon plus 3 house oxygen yields strontium carbonate. So we see that the strontium carbonate cancels out of A and C. They're on opposite sides, so we can go ahead and cancel them. You'll notice that we still have a strontium solid and a strontium oxide and 1/2 of an oxygen that need to be canceled in order to give us the final equation. So that's what we're going to do to equation B to cancel everything out. To do this, we're going to divide it by 2, giving us strontium oxide yields strontium solid plus 1/2 O2. What you'll notice is that the 1/2 O2 cancels, giving us 1 O2. Strontium solid cancels, as well as the strontium oxide. So we are all done manipulating our equations, and we just need to put it all together. So delta H final in this case equals -A. Since we flipped it, it's negative, plus B divided by 2. We divided equation B by 2, so we need to divide the delta H by 2. Plus -C, since we flipped it, divided by 2, since we also divided it by 2. We're doing all of this to the delta H values. So for this, it's going to equal positive 234 kilojoules. You'll see since negative 234 times -1 equals positive 234 kilojoules, plus 592, which is the delta H of equation B divided by 2, plus negative 1,220 kilojoules, which is negative and divided by 2 from the delta H from equation C. So once we do all this, we get negative 394 kilojoules. Now in chemistry, we always want to check if this makes sense. So for this, it's a little hard to see if it makes sense. But what you'll notice is that if you look up the delta H for CO2, you'll find that it's equal to negative 394 kilojoules. So from this, we can conclude that our problem and our solution does make sense. And we finally figured out how to solve these problems. I hope you have a good day.